Well, hello everyone, and welcome to today's webinar. I'm really excited about this one, integrating JMP and Python. This really opens up JMP's capabilities, and I'm really excited to see this presentation myself. This will be delivered by one of our academic ambassadors, Ross Matusalem. Those who attend these webinars frequently, I'm sure you've been the audience for his excellent webinars, and I'm sure this one is going to be no different. Now, there's a poll that's up on the screen. We'd love to get information about the kind of software you use, whether it's JMP or other statistics software. So it'd be great if you could answer that poll for us. If you have a question, now we are going to stop periodically to address questions, but if you have one along the way, please type it in the Q&A window, not the chat window. It just makes it easier to monitor and answer the question. So feel free to type a question. I'll either answer it while Ross is delivering the presentation, or we'll stop periodically and Ross will help answer the questions. Now, there's also a chat window. So if you just wanted to make a general comment to the audience or to us, say providing a link to some resource you use, or making a comment to other folks, like here's what I do, or here's what I like. You can use the chat window for that. But when it's an actual question for us, please type that in the Q&A. And with that, let me check in. Ross, you ready to kick off?
I am, Kevin. Can you hear me all right?
I can.
Great. Well, thank you for the introduction, and everyone, thank you for coming today to learn some tools and techniques for integrating JMP and Python so that you can take some of Python's diverse capabilities as an open source tool and work them into your JMP workflow to expand what's possible with JMP, and wide and easy to use point and click and interactive tool. So I'm just going to begin with an example, as we often do, just to boost your intuition for today's topic. And then after that, I'll review the basics of how JMP and Python can be integrated together. And then we'll work through a few examples to kind of show you the building blocks of JMP and Python integration in action. So I'm going to begin where we're actually going to end today, just to show you quickly one pretty neat example of using both JMP and Python together in the context of network analysis. So if you're not familiar with network analysis, it's the analysis of the structure of connections among nodes or entities in some kind of network. In our case here, we're talking about a social media network. And in that graph that you see, this is just a visual depiction of a network where each point is a node in the network, and then all of the connections are captured by those edges, those lines connecting the points. Here's a data set that we're going to analyze. This is from the Stanford Network Analysis Project. These are actually anonymized Facebook data. So I have data here on 37,655 connections among Facebook profiles. For example, row 1 shows me that Facebook profile 0, where 0 is just an arbitrary numeric label for some individual, is connected to Facebook profile 1. And so we just have simple scenario, 2 columns, each row capturing one of the connections. And as you can see in this example, again, many possible connections in a large network. We have over 37,000 here. So network analysis is not something that is built into JMP, but you can, through a Python package, networkx, perform network analysis. And what we want to do here is quantify the centrality of the nodes in this network, where centrality you can think of as various ways of measuring the importance or impact of nodes on the network. Because we're talking about integrating JMP and Python is a coding language, we're going to look at a good amount of code today, though we won't really be writing code from scratch. I'll spare you watching me do that. Here is a script. It's written in JSL, that's JMP's scripting language. If you're not familiar with JSL, this is a proprietary scripting language that allows you to control JMP to either customize it, to get it to do things it wasn't built to do out of the box, or maybe to automate repetitive tasks. One thing you'll note about this JSL script is that it actually has Python code in it. For example, lines 7 through 10 here that I'm highlighting, we have a JMP function that says Python submit. And what's happening is we're submitting a couple lines of code to actually be run not in JMP, but in Python. So if we scroll down further in this script, and I should mention that after the webinar, you'll all receive a link to view the recording and get all of the materials, all of the scripts and data sets and everything else. If we scroll down to line 135, you'll see a much larger Python submit call. And this block of code that's now colored in purple is a Python script that's actually going to perform the network analysis. And we'll step through how this script works in a certain level of detail later when we cover this analysis in detail. But instead, let's just see what happens when I run this script. And now actually, I could click Run Script right here to run the network analysis script on these data. But actually, Kira Dalbo, a JMP intern who actually created that script for us and built this entire example, bundled that script as a JMP add-in. So I'm actually able to invoke it just by going to the add-ins menu. So let's choose this network centrality measures add-in and see what happens. JMP is prompting us with a launch dialog. This is actually built using some of that JSL code. So I'll select the 2 columns containing our nodes. I have the option to select which node centrality measures of 4 different ones that I want calculated. And then to actually run the network analysis, I'll click OK. So what's happening under the hood is that JMP is passing the information from this launch dialog over to Python. So which measures I want calculated and which columns in the data table are relevant to the analysis. Python now has direct access in memory to the JMP data table, is performing the analysis, and will return the results. So we'll get a table of centrality measures that is a JMP data table. And we'll also get a network graph built by Python. So while this is finishing up running, it'll only take a few more seconds. I'll mention that what we're looking at today is largely new as of JMP version 18, which was released earlier this year. Starting in JMP version 14, you could integrate JMP and Python, but the integration has been completely rebuilt and greatly improved in 18. So I'll talk a little bit more about that as we go along, but let's talk about the results that just popped up here. First, let's take a look at this graph. So this is a graph that was built by Python, but we're now viewing in JMP. You can see up in my menu here, I'm still inside the JMP application. So let's take a look at this graph. I mean, the purpose of today is certainly not to learn anything about network analysis, but you can see some interesting things in this graph. For example, we have certain collections of interconnected nodes that seem to live apart from some of the others and then be connected to the larger network by maybe a smaller set of nodes. For example, right here, I have 2 large nodes that are in a dark color. Color captures the degree. That's just the number of connections. So these dark colored nodes have very few connections, are connected to very few other Facebook profiles. And size is capturing betweenness, which is a measure of how much these nodes lie between different nodes that themselves are not directly connected. So you can think about the shortest path between 2 nodes. And the more times that a node lies along a shortest path, its betweenness measure goes up. So these 2 nodes that I've highlighted here are actually 2 nodes that aren't connected to very many others, but nevertheless, many of the indirect connections in the network run through them. Over here, I have a JMP data table of centrality measures, degree, betweenness, and a couple others that were computed by Python, but now returned as a JMP data table. And I think this really highlights some of the benefits of using JMP and Python together. For example, let's say I wanted to just look at the distributions of these 4 centrality measures. Well, instead of having to code all of that up in Python, with 2 clicks, I can get box plots, histograms, and summary statistics for all of them. And of course, because this is JMP, all the graphics are interactive. So I see one node in particular here, hovering over it. That's row 108 with a degree measure of 1,045. So that is 1,045 different connections. We might guess actually that that is the big yellow node lying in the background here. Or I might want to, let's say, look at the relationship between degree and completeness. So again, instead of having to code something up in Python, it's pretty easy to put together a quick scatter plot in Graph Builder. And in fact, even just doing nothing more than dragging my axes, zoom in to maybe find, let's see, a few different points that are high on betweenness, but maybe relatively low on degree. So I've selected 4. Now I've found 4 points here that have very few connections, anywhere from 2 to 6, but relatively high betweenness measures. So we've identified a number of nodes, much like these two that we highlighted before, in a much easier way than having to code it ourselves, in this case, using interactive graphics. So what we just did here is, through a blending of JMP scripting language and Python code, we have a custom-built tool for network analysis that utilizes both tools and their strengths to get JMP to do something beyond what it was built to do out of the box. And I think that's just a great use case for JMP and Python integration. So let's talk a little bit more about use cases, actually, before moving on to any of the details of how all of this works. So what we really just did here was augment JMP's capabilities. So as I said before, JMP is a wide tool, especially JMP Pro, from basic to advanced statistics, modeling, machine learning, design of experiments, lots of data visualization. But of course, Python as an open source tool brings an extraordinary number of additional capabilities. So with JMP and Python integration, you can use JMP as your main data analysis hub, calling out to Python when it's necessary to augment JMP's capabilities. This could include, like we just saw, actually building a graphical user interface in JMP as a front end to some kind of Python routine. This is particularly great if maybe you want to build a new tool for users that don't even know how to write Python code. Somebody could have just run that network analysis add-in that we saw without ever knowing that Python was involved behind the scenes. Now, some of you who are Python coders, and based on our poll results here, I see that we have a good number of Python coders attending today. You probably have some existing Python scripts. So these implement certain routines or workflows, and you might not want to have to rebuild those in JMP, even if JMP has all of the capabilities that would allow you to do so. So there's no need to reinvent the wheel. If you have a Python script that you want to use, but you also want to use JMP, that's great. You can actually run your Python code directly in JMP on your JMP data tables, or even run them at the front end to pull data in and return the data to JMP. And we'll actually see an example of that as we go along. So that actually refers more, or in part, to perhaps importing unsupported data file formats. Example 2, if you look down below, is going to focus on that. So JMP can open many file formats automatically, but in the event that you have a file format that's not supported, you might be able to use Python as a bridge. And speaking of a bridge, you might actually be able to use Python as a bridge between JMP and other software. So much like JMP integrates with Python, many other software packages do as well. And if you need to coordinate between JMP and some other software package, Python might be able to serve as a common language between the two. And finally, this being an academic webinar, JMP and Python integration presents a really strong combination for use in the classroom with students. Many statistics and data science instructors argue that students should be exposed to multiple tools, and perhaps even at least one open source tool and one proprietary tool, to be able to expand their skill set, their technical skill set, so that they're better prepared for their careers. So using JMP and Python together in a single course might be able to help achieve that goal in a really streamlined way. So these are just a few of the reasons that I think any of us might have for integrating JMP and Python, and you may think of some of your own as well. But let's talk now how JMP and Python integration works. From a really basic level, I want to talk about kind of the building blocks of how JMP and Python can talk to one another before moving on to any specific examples in detail. So how does it all work? Well, I mentioned earlier that we're talking largely about new integration features in JMP 18. How it's all working, or what it's all based on, is JMP installing now as a version 18 its own Python environment, Python 3.11 specifically. You could integrate JMP and Python starting in JMP version 14, actually, but JMP would integrate with your own Python environment or environments that you had installed separately on your machine. And this introduced additional challenges to get the two pieces of software to talk to one another properly. But now in JMP 18, JMP has its own dedicated Python environment, and the integration just works much more seamlessly. That environment actually comes pre-installed with a JMP-specific Python package that provides a number of functions for bidirectional communication with JMP. So not only does JMP have its own dedicated Python environment that we know it can talk to, but that Python environment actually comes with its own package that allows JMP and Python to work together more seamlessly. And we're going to talk about that Python package in just a moment here. Now, I mentioned building blocks. Let's talk about some of the building blocks. So the different things that you can do when we're talking about Python and JMP integration. So what's possible? First, you can write and run Python code from directly inside JMP. So if you go to, as of version 18, the File menu and New, you will find New Python script. And if you select that, it will open up a JMP script editor that's actually Python specific. So if you write any code, let's just see an example here. I said I wasn't going to write code. I really meant I'm not going to write very much code. So let's say I import this JMP package, or actually, in this example, I'm going to import another package we'll talk about in a moment, the JMP utilities or JMP utils package. And then what I'm going to do is ask it to list for me all of the installed packages I have in JMP's Python environment. So let's run that script and see what happens. So I've loaded the JMP utils package, and now down below in our log window, I can see all of the installed packages down here. This is just a quick example. So what I've done is gone to File, New Python script in JMP, run the script inside JMP's interface, and it's actually running this in Python for me using some JMP-specific functions that we'll talk about more in just a moment. In addition to being able to write and run your Python code in JMP, JMP's Python environment has direct access to the data tables that you have open in JMP, so direct in-memory access. We'll actually see an example as we go along, but this makes it really easy to actually just run Python code directly on your JMP data table without any need for an intermediary. For example, exporting your JMP data table as a CSV and then opening it in Python and running something there. You can also send variables between JMP and Python, and we'll see how to do that. So things like numeric or string values or lists or matrices from JSL to Python or from Python to JSL. You can send them back and forth. We actually already saw an example of embedding one language in another. In our case, in that network analysis, we embedded Python code inside a JSL script, and you can do the other way as well. So embedding JSL inside a Python script. And so with Python and JSL being able to send information and variables between one another, Python having access to JMP data tables, being able to blend the two languages in a single script means you can really seamlessly integrate capabilities from both software packages here. And then finally, as we just saw, you can display Python messages directly in your JMP log window as well, which is, of course, very handy. So now I want to talk to you about a few important Python functions to know and some important JSL functions to know when you are actually coding in JMP and integrating JMP and Python together. So in this section, you're going to find just a short list of some of the Python functions that I want you to be aware of. This is in both the JMP package and the JMP utils package that come pre-installed with JMP's Python environment. You'll notice in the notes here, it says see help scripting index for more information. So if you're not familiar with the scripting index, it lives down here in the help menu. This provides an interface for getting information like descriptions and syntax and examples, including a code sandbox to play in for all of the coding functionality in JMP. Now, if you want to know about the Python functions, go to the drop-down at the top and select Python. You'll notice on the left here now we have the JMP Python package functions by group. We have each individual function in the middle here, and then for any one that we select on the right, we get descriptions with syntax, and down below the examples that we can run. So let's just take a look at a couple first. The first thing you might be thinking is, oh, well, if I'm going to be using a dedicated Python environment with JMP, how do I configure it? How do I, in particular, install new packages? You're going to use the jpip function for that. So let me go to JMP utils here and jpip. I actually just coded a quick example of this live. So this is the equivalent of calling the pip function inside Python. You can see an example of the syntax here. So once you import jump utils package, you would just use jumputils.jpip. And then the arguments are whether you want to install or uninstall, and also with optional arguments like upgrading. And then a single space-delimited list of the packages that you want to install. Note that sometimes there are multiple examples in the scripting index. So I can go to example 2, and in this case, here we have the one that I just coded by hand, where we import jump utils, and then we actually ask it to list those installed packages. And so here we go again. You'll notice that what I've run here is that same code that we saw before, and it's printed out to this log window. This is a self-contained code sandbox. You can run these examples or even modify them if you like, just to play around and figure out how some of this stuff works. Now, something else you might want to do is actually be able to run Python code on a jump data table. And so you need to know how to reference a jump data table. So when we use menu items in jump, for example, we go to analyze distribution, that'll be run on the currently active jump data table. That is the most recently selected one. So how do you reference the currently active jump data table? Well, that's just the jump package function current. And so let's go under functions at the top level here, and you'll find jump.current returns a data table object for the current jump table. So let's run this example here and see what happens. You can see that we have opened the big class sample data set. So that's what this line did right here with jump.open and then the path to that data set. And we said print the current data table. And what that did was right here in our log, it printed the name and then size of that data table, 5 columns by 40 rows. And just to show you again how this is a sandbox that we can actually play with a little bit, I'm going to go ahead and reference just the first column in the current data table and print that instead. And so when I hit play, you can see now I've printed the information of that first column. So the column is called name. It has 40 rows. Its data type is character. Its modeling type is nominal. And so notice, data type character, modeling type nominal, that's jump language. Those are column properties in jump, and that's what we printed out here. So this jump.current and these others listed below it, these actually return jump data table objects. And of course, then from there, if you need, let's say, a pandas data frame to be able to run a certain function on your data table, it's easy to convert between the two. And we'll see an example in just a moment. Now, I'm not going to walk through all of these additional functions in great detail in the scripting index. I'll leave it to you on your own time to do that, but please do. The scripting index is a great way to learn about the other functions I'm about to tell you about, as well as the many more that you see listed here that we don't have time to talk about specifically. So sticking with referencing data tables, if you want to reference a jump data table by name instead of just the currently active one, use the jump.table function to do that, where the argument to jump.table would just be a string that is the name of that table. If you want to initialize a new data table, that would be jump.datatable, and then arguments there could include the name for that data table and the number of rows. And then finally, if you want to intermingle JSL code in a Python script, you can use the run_JSL function. And you'll find some nice examples in the scripting index here. For the sake of time, I won't run through them, but here's one, as it says in the dropdown, that actually opens a jump data table, but then uses some JSL code right down here to change some things about that data table. In this case, reformatting one column and then setting a display width for another one. So please do go to the scripting index, use this drop-down menu to select Python to learn about all the functions in this jump and jump utils packages that you will need to use to get the integration working. Now I'm going to go back to all categories and then scroll us on down to some important JSL functions for integrating with Python. Starting in jump 14, when Python integration was introduced, there were a number of JSL functions for doing that, and that remains. So there are JSL functions for integrating with Python. You can find them in the Python group here. So let's just talk about a few. Just like before, of course, you can select any one of them from this list right here. Let's start with the first one, Python submit. This is just the basic way to submit Python code to be run in Jump's own Python environment. So in this example, we can see that the Python code, which is contained right here inside the Python submit function, declares a new string variable containing this sentence, and then a new variable a that just equals the numeric value 200. So we declare that, and then down here, we tell JSL to go get those variables from Python. So Python get the string, Python get a, that numeric value, and then show them in our log. So let's run that and see what happens. So you can see we have printed those two variables in our log, and those are being printed now as JSL variables because we were able to get them from Python, which is where we declared them. So you can use this Python get function to get variables from Python. And I should mention here what types you can get. You'll find those in the scripting index right here. And same goes for Python send if you want to send a variable or variables to Python. And then finally, we have Python execute, which is kind of like Python send, Python submit, and Python get all in one go. So if we go to Python execute here, you'll see that the syntax is a list of inputs, a list of outputs, and then the Python statements that you want evaluated. And you can find a nice example down here. Again, for the sake of time, I'm not going to walk through these in detail, but go ahead and have a look at the two examples in the scripting index for Python execute. And I'll just stress it one more time. If you're just getting started with integrating JMP and Python, please do check out the scripting index for both the Python functions and then also the relevant JSL functions, because there are many more very useful ones that we just don't have time to talk about in detail. But I'm hoping that the ones that I've just described to you are enough just to get you started. So we're going to work through now 3 examples, each one in 5 to 10 minutes. But before we do, Kevin, I'm going to stop and see what questions we might have.
Yeah, there's only one that we have in the Q&A window. I believe the answer is yes, but before I answer it, I want you to take a look to confirm.
Okay, I see. And the question is, can I use my own environment or install any package for JMP's environment? So you can't use your own environment anymore. JMP will use its dedicated environment, but as we just saw, you can, of course, install any package you want into JMP's environment to make it your own. I see somebody asking, can you run JMP from inside a Jupyter notebook? No, that's not possible at this time. If you go to community.jmp.com, there's a section called the JMP wish list where you can request new features to maybe enhance the JMP and Python integration further. So let's go ahead and move on for now, and I'll return to questions again at the end. If you've attended these before, Kevin and I typically will hang out as long as it takes to answer every question that's come in. And I see some folks, you have your hands raised in the participants list. If you have a question, please do type that into the Q&A. That's the best place for us to see them. So now let's work through 3 examples. I'm going to point out different places where all of these building blocks that I've just described are being used to achieve a certain general purpose or use case. And example number 1 is augmenting JMP's capabilities, in particular performing something known as an isolation forest analysis. So I don't want to get too deep into the weeds on exactly how this works, but an isolation forest analysis, which is not included in JMP or JMP Pro, is a way for detecting anomalous data points, or what we might call, let's say multivariate outliers. And we have a little diagram here for kind of how it works. You recursively partition the data at random cut points along your variables, and then figure out how many random partitions are required before you're able to completely isolate a point. And if it doesn't take that many on average, that point's probably an anomaly. So here's some data that we're going to run an isolation forest on. Again, this is an example of augmenting JMP's capabilities. So if I have these data, at first I might choose to use JMP's graphical capabilities to explore them. So again, maybe I want to look at the distribution of these variables, and I can see both are bimodal. I can use the interactive graphics to find that, if I highlight the low points in X1, it seems to highlight almost exclusively the low points in X2, so the same must be true of the high. So it looks like I have maybe 2 different clusters of points here. In Graph Builder, let's go ahead and actually take a look at the scatter plot. Okay, so I can see that what we have here are 2 clusters of points. and a number of data points kind of floating out in space away from those clusters. And maybe those are anomalous points that we would want to flag. And in this case, we're going to choose isolation forest as our method to do that. But of course, JMP doesn't do that. So we're going to use Python instead. Here's a Python script that's going to run the isolation forest analysis on our JMP data table. I'm going to run it first right now just to show you what it does, and then we'll step back through and I'll explain in just a little detail how it works. So I've run this script. What it's done is written for me a new column to the data table that says anomaly label, where we have values of 1 and -1. -1 are those that have been labeled as anomalous points. So these labels were actually calculated in Python, returned to us in JMP. And now I can pull up this graph that I was working on and maybe embellish it with these labels. And now I can see the isolation forest has done a pretty good job of identifying which points are anomalous. I might take issue with a few that seem to be right on the edges of some of these clusters here or here. But for the most part, here, I'll even just use JMP's interactivity to highlight those. It looks like it's done quite a good job at distinguishing between the anomalous and non-anomalous points. All right, so how does this script work? Well, let's go back up. I have, for each of our examples, a quick list of kind of the high-level things that the script is doing. Let's point out where in the script it's done so that you might be able to explore this and maybe modify this example on your own. First, of course, we are writing and running the Python code from inside JMP. So this, to be clear, is a Python script. It is not a JSL script. And again, you can go to File, New Python script to open up a Python script editor and get started. At first, we import the necessary packages. So note that, for example, using NumPy or Pandas or scikit-learn, you would first need to use that jumputils.jpip function to install them before attempting to import them. Next, we run our Python code directly on our JMP data table. So you'll notice that I create a new variable, dt, data table, and I assign to it the current JMP data table, jump.current, which we saw before. And now just for expository purposes, down here I have 3 lines of code in 18 to 20 that do different things with that dt variable, that JMP data table object. This first one just prints a statement that says number of calls and then the number of columns in that data table to our log window. So let me run that. You can see we have num calls 3. And so this dt.ncalls, this is from the JMP package. Ncalls will operate on a JMP data table object and just return for you the number of columns. Here I'm saying print the information for the first column. We saw an example of this with that big class data set that we were working on in the scripting index. So here again, I get the column name, the number of rows, the data and modeling types. And then finally, this actually prints the first 10 values of that first column, so that X1 column. So here we have that list down here. These are just 3 examples of working with the JMP data table. They're not relevant to the isolation forest. I just put them in there for your own purposes for playing around with when you get your hands on these examples after the webinar. Now, just to stress something very important here, Python has direct access to our JMP data table in memory. So let me show you a little example of what that means. I'm going to copy this value so that I have it. And then this first X1 value, I'm going to change it to 100, just some value that's clearly different from all the others in that column. So I've changed the value of the data table. I'm going to rerun line 20 that prints the first 10 rows. And so this value right here has just been changed to 100 in the data table. Now, if I run that line of code, that 100 is here. So even though I did not reassign DT to the current JMP data table, when I rerun line 20, it just pulls the data from that open data table, whatever it happens to be. So we have direct in-memory access live to whatever data table you're working with. All right, I'll put the original value back, and heck, just to demonstrate it one more time, we will run it and you can see that value is back where it was. I should actually mention, I forgot to mention this at the top, I find it quite handy to, while I'm coding inside Jump's script editors to view the log right inside the script window, as opposed to pulling up the log here. And if you want to do that yourself, you can always right-click and choose Show Embedded Log to pull that log up. Okay. So we're running our Python code directly on a Jump data table. We've seen that we are writing Python outputs to the Jump log. So when I do, say, print, it will print even the outputs from that Python code directly below. And then we finally run our Python analysis, the isolation forest, on our Jump data table. Crucially, you can't run that directly on a Jump data table object. So right here, just a few lines of code. This was also written by Kira Dalbo, a Jump intern for me here, to convert a Jump data table to a pandas data frame. So go ahead and steal this code and reuse it. It basically just, as you can see, just cycles through each of the columns in our Jump data table and then writes each one to a column in a pandas data frame and returns that data frame. So 24 through 28, we're defining this Jump data table to pandas data frame function, and then I'm running it on our Jump data table and returning a new table I'm just calling X. Here I actually do the isolation forest analysis and get those labels, those anomaly labels out. And then finally, I'm returning those results back to our Jump data table, and that's what lines 40 through 42 do right here. So dt.newColumn, that's from the Jump package. So I'm creating a new column. In fact, here, we'll do this live. Let me delete this. So if I run just this line of code, I should have also mentioned you can always just highlight one or several lines of code and click Run Script to run only those lines. So that line creates the new anomaly column. Here, I'm just going to convert the labels from up here to a list format so that I can populate it into our Jump data table. And now I just assign that list to this data table column that I'm referencing by name right here. So there you have it. You look, we have 42 lines. A very large amount of that is comments and white space. And we even have these 3 lines here that I've put in, again, just for your own learning purposes that don't actually have anything to do with the analysis. So pretty simple code to be able to do something relatively sophisticated in Python and return the results back to Jump for us. So this is the first example of augmenting Jump's capabilities, and these 4 bullet points are the main techniques that we saw. Let's move on to our second example here, which is importing an unsupported file format. So in Jump, if you go to File Open, you can open not only Jump data tables, but many other types of files. Of course, your CSVs and other flat files, Excel files, maybe something like a JSON or XML file. You can read data out of a PDF. You can read data from some other supported statistical packages. But of course, there are some file formats that Jump can't read. One of those is an Apache Parquet file, which some of you may be familiar with. So this is an open source file format that's quite common in data science and big data analysis. Jump doesn't read Parquet files, but Python does, and we can use Python as a bridge to get a Parquet file into Jump. And so to do that, let's first go get ourselves a Parquet file. Here I'm at the Kaggle website. If you're not familiar with Kaggle, it's they host data science competitions and maintain a library of materials, data sets, and other things. So here I have the page for a data set on the U.S. National Basketball Association. So these are sports statistics, basketball statistics from the top professional basketball league in the United States. You'll notice we have a list down here of different files that we can download, and they're all .praq. So these are all Parquet files. So without, say, Jump and Python integration, the thought might be, oh, well, if I want to load one of these files into Jump, I'm going to have to find something that does read Parquet files, and then from there, export a file format that Jump does read, maybe a CSV file, and then import that into Jump. But we're just going to do it directly with Python instead. So let's download this total.parquet here. I'm going to save it to my desktop. Just to show you, let's find where it was placed on my other desktop. Here we go. And so, of course, just to reiterate, if I go to File Open and I want to open this total.parquet, it's grayed out for me on my Mac Jump is not going to let me attempt it because we know that it does not support that file type. But here I have a script that will import Parquet files for me. So as we did before, let's just run it and then I'll walk back through and explain to you how it works. So we are, again, using a Python script here, not JSL. I'm going to run it, point it at total.parquet. And here we have that Parquet file imported as a jump data file right here. And so we have, in this case, 12,626 rows of data. So player by year, and things like the number of games they played, how many field goals they made, how many three-pointers they attempted, and so forth. We're not going to bother looking into these data, though. If you're a basketball fan, you might want to after the fact. There's a lot of interesting stuff in here. Let's instead go back to our script and talk about how it worked. And again, I've highlighted in the notes right here just a few of the core JMP and Python integration techniques that are included. Let me show you exactly where they are and how they work. So again, first we import a number of JMP packages. I actually notice now I'm importing PyArrow here, and I don't think I'm using it. I think you can do all of this with pandas, so pardon that. I'll clean that up before we send it around to everybody. So first things first, when I ran that, if you recall, I was prompted to choose a file. So that prompt where I was able to select which file I want to open, that was a jump prompt. That was jump asking what file I want to open. What I'm doing is running some JSL code inside a Python script that prompts me for the file. That's what's happening here on lines 13 through 20 with the jump.run JSL function, another Python function in the jump package. And then all of this code that you're seeing, lines 14 to 19, this is JSL code. For example, pick file is a JSL function that opens up a jump file browser window. And when you select a file, it returns the path to that file. We save that as file path. Then we parse it so we can get out the directory and the file name separately. We call the directory pickdir and the file name pickfile. And then from there, we actually pass these values. These are two string variables to Python. We're using JSL in this case to do this, some of these JSL Python integration functions. So here we have Python send pickdir, Python send pickfile. So these string variables are now available in Python using the same names that they had in JSL. So moving along, starting around line 24 down here, we actually import the Parquet file. So we're taking, let's say, the pickdir variable and also the pickfile variable and feeding those to Python functions like pandas read Parquet to be able to read that file in as a pandas data frame. And then if you recall before, I had a quick custom function that converted a jump data table to a pandas data frame. Well, here's going in the reverse direction. So down at the very bottom, what we are doing is creating a blank data table. So that's jump.datatable. I'm just calling it untitled, and it has the length of that pandas data frame. And then I'm just populating it column by column with each of the columns from that pandas data frame that we read in. And so this is how we were able to then create and modify a new jump data table. We create it on line 37, and then we populate it with values with this simple for loop in lines 38 to 40. So that's example 2. We've seen how to run some JSL code from inside Python, pass variables from JSL to Python, and recall that you can use Python get in JSL to send them the other direction from Python to JSL. And then we created and modified our jump data table at the end. So let's now go back to, here, I'll get rid of our basketball data file here. Let's go back to the example that we started with, which was creating a jump graphical user interface for a Python capability. And I think this is a particularly powerful use case because it allows anybody who knows how to code in JSL and Python to build custom applications that blend functionality between the two and that users can use solely via point and click without ever having to even know that Python is involved. And so just to remind you here, let me pull up the files that we had before with the network analysis. So we had these data, again, anonymized Facebook data, where each row represents connections between two Facebook profiles. And we were able to, via an add-in, compute centrality measures for every node. We had just over 4,000 in total, and produce this network analysis graph down below here. So how does all of this work? How we can start with this data table and end up with the centrality measures and that graph? Well, as I hinted at the outset, this works via a JSL script with embedded Python code. And here is that script. We saw it at the beginning, and you'll note that it is a fair bit more complex than the other two examples, but let's actually walk through what's going on in this script in just a little detail. Here again, we have a bulleted list of the main JMP and Python integration techniques that are at play here. So we're running a Python routine via JMP's point-and-click graphical user interface. If you remember, we actually invoked it from the add-ins menu, and it opened up this network analysis launch dialog here. So let's go find the code that does that. We actually have it commented right here, starting on line 85. Here's the code that builds that launch dialog. For example, here, JSL's new window opens up a new window. And here we have a message that we send to that object saying that it should be a modal dialog box. We have, for example, down here, some structuring of that box. So list box is just a way of structuring content in the box horizontally, or I should say in the window. vlist box structures it vertically. Text box right here, select numeric columns. This is just a way of literally writing the text, select numeric columns into the box. Or call list box right here. This is a JSL function that will list all of the columns in your data table and allow you to select some for analysis. So I'm not going to go through all the ways in which that dialog was built. You can see the code here for building that custom JMP launch dialog. And I know a lot of users who've actually done this. They've built, even just in JSL, completely custom JMP tools with their own launch dialogues. What I recommend if you're thinking about doing something like that is take this example, play around with it, change it, make changes to the code to see how it changes the dialog box itself or the values that it returns when users use them. And even just take and modify this code to make a dialog box for yourself. Now we also see here how to embed Python code inside a JSL script. We talked about it before. This is using Python submit, which again, just for those of us who aren't on JMP 18 yet, this was available, Python submit, starting in JMP 14. And you can use this if you're not on 18 to submit code to your Python environment, as opposed to the pre-configured one in JMP 18. So here's the block of Python code that then takes the information from that launch dialog and does things like create the network graph, or in this case, calculate the centrality measures, or creating a pandas data frame right here of all of those centrality measures that then we use to create a JMP data table. So it's well beyond the scope of today's webinar to go through line by line and tell you what all of this does, but please do browse this example. Look for all of the comments that Kira has put in here for us to be able to figure out exactly what all of this is doing. Now, of course, as we've kind of seen already, we can return our Python results as that JMP data table. And so right down here at the end is where that's happening. So we've created, in this case, JMP.datatable centrality DT, and then we go ahead and, as we saw before, loop through and populate its columns with the necessary values. Now, finally, one new thing we haven't seen yet, and I think this is something a lot of us are probably going to want to do at some point, is view Python-generated graphics inside JMP. So JMP can make many, many different kinds of graphs, and it really excels in interactive and even 3D graphing. But of course, there are some graphs that it doesn't do natively through its point-and-click interface, and network visualization is one of them. So we built the network visualization as I highlighted. Let's get back up to where that was. Yeah, starting here on line 146, create the plot image If you're familiar with matplotlib, then some of this syntax probably looks somewhat familiar to you, including the ability to save your plot using plot.savefig. Now, I'm going to point you to, I think, a nice little trick for being able to view your Python-generated graphics in JMP. What we've done here is actually saved the graph to a path contained by this variable, temporary path, and then down below, we actually use JSL to open that same file and view it. And so JMP can open graphics files, for example, PNG files, and that's all we're doing here. And what I've done, or what the script does up above, is assign to this temp path variable my operating system's temporary directory. So whether you're on Mac or Windows, there is a temporary directory where your operating system is writing files, and then after a set period of time, it will clear those files away. So we've just found what that directory is using os.path.join here, and creating the path to that directory plus the name of the file that we want. We save it there, and then down at the very bottom, open that file in JMP, and then even just to clean things up, we use another little bit of Python code to go ahead and delete the file. So what ultimately happens is the user gets to see that graph, and then if they want to save it, they can go in JMP to File Save and save it as they like. Now, finally, this is also an example of passing variables from Python to JSL. So we generated this temp path variable in Python, and then we used, in this case, on line 228, the Python get function in JSL to grab that value so that we can feed it to our open function here to view it inside JMP. So these are just a few of the techniques that are demonstrated in this last example here. But one thing that we have yet to talk about, and I'll just point you in the right direction to get started, is how you can actually build a JMP add-in that uses these Python capabilities. You can take any JSL script and convert it to an add-in so that you will have a menu item in your add-ins menu to be able to launch that script or to run it. And that's all that this network centrality measures add-in does. It's literally the same as clicking run script right here. So to build an add-in, once you have a JSL script, and even if that JSL script incorporates Python code, go to File, New Add-in. You'll be presented with a series of fields to fill out to specify the add-in. For example, what is its name right here? Maybe what's the minimum JMP version? So in this case, because it's using the new JMP and Python integration, I would say 18. You can declare what the menu item should be called. So for example, I'll have it live in the add-ins menu, or I could even add a submenu, and then I can specify what the menu item would be called. So literally saying, well, it should live under add-ins, and I want it called network centrality measures. And then finally here, declare a startup script. So I could take this script and copy and paste it into this box, or just reference that file, which will then get bundled with the add-in. Either way works. There's some other ways of configuring your add-in for additional functionality. This really isn't meant to be a tutorial about building add-ins, so I won't say any more. But once you do this, you'll actually be creating, when you save, a .jump add-in file that then any user can install and have the add-in in their menu. And I'll go ahead and provide that add-in file with the rest of the materials alongside the recording. And again, you will all get an email for that. Last thing I want to mention, this is something that I meant to mention just a moment ago. If you are going to do this, that is build a GUI front end for some Python capabilities, one challenge you might encounter is that folks may not have installed all of the necessary Python packages for your tool to work. So have a look at the first blocks of code in this example for a way to handle that. So in this case, let's take a look at what it does for the network X package that actually runs the network analysis. What we're doing here on line 13 through 15 is using the try function in JSL to try to, in Python, import network X. And what this code is saying is that if that fails, then what you should do is use Python install packages, which is the JSL equivalent of that jpip function. to install Network X and then import it. And so I tested this out. It works even if you don't have any of the necessary packages installed at first. This script will detect that you don't and install them for you. And I think this is just generally a best practice if you want to deploy one of these fully point and click tools that incorporate Python. Otherwise, you may get errors and users not understanding exactly how to troubleshoot them themselves. So I just wanted to establish that. But more generally, and just to wrap up, JMP and Python integration allows you to, build these Python capabilities, of which there are many, into your JMP workflow, whether you want to just augment JMP's capabilities or be able to kind of blend JMP and Python capabilities into a single tool, whether you want to code it and have people run the scripts, or whether you want it to function entirely through JMP's graphical user interface. This greatly expands what you're able to do with JMP and how you're able to use JMP as a general data analysis hub. And I'm quite excited now with 18 and how much easier it is to integrate JMP in Python. Excited to see what all of our users are able to do with it. So with that, I will stop talking, have a sip of water, and see, Kevin, if we have any questions in that Q&A that we should address before we wrap up.
I apologize, Ross. There's construction going on like 20 feet from me, so you probably hear loud sawing.
Surprisingly, I don't.
There is a question that's in the Q&A, but I think you actually just addressed it when you were talking about the syntax of Python.
Okay, so I see the question. It says, does the JMP script editor enforce Python syntax? I don't know exactly the best and most accurate way to interpret the term enforce there, though that might be my own shortcoming if that's common parlance. But the JMP script editor does have Python syntax highlighting to it. And again, if you get your syntax wrong, and it would trigger, a Python error message about that syntax being incorrect, that error will get printed to your JMP log to help you troubleshoot.